Now we came to the last section of my presentation. This section is lengthy and it is more difficult. Um, as I said previously, International Energy Agency, on a report dated May 19, 2021, explained in detail, in a technical manner, how to get to net zero in emissions. Now, perhaps it's easier to read a book that was published by Bill Gates. It's called How to Avoid a Climate Disaster, and that was also published in February 16, 2021. And he explains again how to get to zero emissions, but perhaps it's easier to read Gates's book, and I would recommend to everyone to read that book. I've read that book in detail and transferred some of the information from these two publications to this part of my presentation, but also since 2021 have read so many other documents on how to get to zero emission and the developments. So we will review all that in this section. Yes, the topic of this part 6 is what can we do to reduce emissions. Okay, let's start with some information we got from EPA. This is 2010 information. So it's been a few years since, but nevertheless, I haven't found anything newer on this. It groups where emissions come from. First of all, the industry is responsible for 21% of the emissions. That is happening mostly by burning fossil fuels to generate energy, but it also includes emissions from chemicals, metallurgical, and mineral transformation processes not associated with energy consumption, and emissions from waste management activities. Then there is this other energy group, which is responsible for 10%. This source of greenhouse gas emissions refers to all emissions from the energy sector which are not directly associated with electricity or heat production, such as fuel extraction, refining, processing, and transportation. Now, for electricity and heat production, this is responsible for 25% of the emissions. This is burning of coal, natural gas, and oil to generate electricity or heat. And this is the largest single source of global greenhouse gas emissions. Agriculture, forestry, and other land use also come with a large percentage, that's 24%. These are the greenhouse gas emissions from agriculture, cultivation of crops and livestock, and deforestation. This estimate does not include the carbon dioxide that ecosystems remove from the atmosphere by sequestering carbon in biomass, dead organic matter, and soils, which offset approximately 20% of emissions from this sector. Now, transportation is responsible for 14% of the emissions. Again, fossil fuels burned for road, rail, air, and marine transportation. Almost all 95% of the world's transportation energy comes from petroleum-based fuels, largely gasoline and diesel. And there is the buildings. This is burning fuels for heat in buildings or cooking in homes. Here is the pie chart showing the same. As I mentioned before, while the gas emissions are going up globally, USA is actually controlling it and reducing gas emissions since 2007. If you look at this, the colors indicate different energy sectors. This is USA. We have more emissions from transportation than the global averages. But the blue, which is electric power industry, this is where most of the reduction is, because a lot of coal generated power plants are closing down, replaced by either renewables or mostly by gas. Now let's discuss some of the details of industrial emissions. Steel and cement production are responsible for nearly 7.5 and 5.5% each of the total global carbon dioxide emissions. Cement, USA produces more than 96 million tons of cement, nearly 600 pounds of cement per adult. China produces 10 times more, but they have a larger population. Steel, about the same quantity, 600 pounds of steel per adult in the USA is produced. The demand for steel and concrete are increasing exponentially, even though the steel is recyclable. Then, of course, we've got plastics, aluminum, fertilizer, and paper. Cement is the most difficult. Carbon dioxide is formed as part of the process. Limestone, when heated, makes cement and carbon dioxide, and this is the formula. Of course, in addition to this direct chemical process, heating process is also producing, that is burning of coal or fuel, is also producing carbon dioxide. But the heating process can be modified to use hydrogen gas instead of fossil fuels to reduce carbon dioxide emission partially. Cement is currently so cheap that any new innovation will increase the cost. This industry needs government incentives to decarbonize. Carbon capture technology will undoubtedly be required, but the cost will be high. Heidelberg Cement plans to build the first carbon-neutral cement plant in Sweden by 2030. The fourth largest cement producer in the world is aiming to capture 1.8 million tons of carbon dioxide annually, but obviously they need help from the government. Steel and aluminum production can be decarbonized by either electrifying the process or burning hydrogen in place of fossil fuels. Cost premium for these changes for steel and aluminum is relatively modest and can be reduced to zero in time. It is modest in proportion because steel is expensive, not like cement. Another interesting thing is that European steel manufacturers today emit less carbon dioxide than the Asian manufacturers. So there is a lot of efficiency factor we are talking about. Steel is recycled today in most countries, and that has a major impact in reducing emissions, of course. Now, plastics manufacturing uses fossil fuels for heating. That can be reduced by using hydrogen gas or electrifying the heating processes. Plastics use carbon containing materials, natural gas as raw material, so they can be used as a carbon sink as well. If processes are developed to use air in place of natural gas, that would reduce carbon dioxide in the air. Better still, if plastic manufacturing processes can be coupled with carbon dioxide producing processes, i.e. power plants, cement plants, we could kill two birds with one stone. ExxonMobil is planning first world-scale blue hydrogen plant at their integrated refining and petrochemical facility in Baytown, Texas. What is blue? Well, there is green. Green hydrogen is generated from air and water. There is gray. And there is blue somewhere in between. Once operational, the new plant could produce up to 1 billion cubic feet per day of blue hydrogen, helping cut fuel-related emissions at the existing complex and nearby industrial facilities. Basically, they are using some of the materials, gases that they produce in their refinery, and that's why it's called blue. It's not green sources. Manufacturing has gone through many innovations within the last 100 years. It's going through many new innovations in the developed countries today with changing objectives. One of them is the reduction of carbon dioxide emissions. These developments can and must be accelerated by government incentives such as carbon taxes. Industrial emissions can be reduced to zero by recycling, electrifying or using hydrogen gas in place of fossil fuels, using carbon capture processes to remove the remaining emissions, or managing the accidental leaks to atmosphere. That is an important factor too. Let's talk about power generation emissions. Power generation alone causes 25% of the entire carbon dioxide emissions globally. Now, just to give you some idea, energy unit is 1 watt. That's a joule per second. Globally, worldwide, 5,000 gigawatts, that is billion, of power is generated. In USA, we are responsible for roughly 20%, 1,000 gigabytes of power generated. Gigawatts again, billion watts. A mid-sized city require 1 gigawatt of power. A small town, 1 megawatt, that's a million watt of power, and the average American home generates, consumes about 1 kilowatt of power. In 2019, according to International Energy Agency, global energy is produced from the following sources: 38% coal, 2.9% oil, 23% natural gas, 10.1% nuclear, 16.2% hydropower, 0.5% geothermal, 4.8% wind, 2.1% solar, and about 2.4% biofuels and waste. In other words, nearly 2/3 of global power today is generated by burning fossil fuels. IEA calls for end to new oil and gas exploration if global warming is to be kept in check. Of course, as we heard this year, both ExxonMobil and Conoco are actually expanding their oil production. One other factor that we have to talk about is the subsidies. Combined subsidies for both consumption and production of fossil fuels in 2019 totaled $478 billion in 77 economies. This is the IEA and OECD claim, released in June 2020. US alone subsidizes fossil energy by $20 billion annually. In many oil countries, oil prices are subsidized to make it cheaper for their citizens. However, that same money can be given to their people by lower taxes or some other means. They don't have to subsidize oil. The power demand will increase as industries, such as AI, use more power or hydrogen gas to replace the fossil fuels. Hydrogen gas is produced by the electrolysis of seawater. Therefore, it is a power-intensive process. Some scientists believe surplus renewable electricity produced during hours of slack demand can power electrolysis machines to make hydrogen, eventually providing carbon-free energy when demand is strongest. Siemens Gamesa is providing wind turbines with electrolyzers to produce hydrogen gas. According to an article in Wall Street Journal, the average cost of solar power fell nearly 90% between 2009 and 2023, with onshore wind declining by 2/3. Onshore wind costs now about $40 per megawatt hour. Fixed axis solar costs $42. Coal and offshore wind costs about $75, and natural gas costs $92. Of course, these costs of coal and natural gas are changing, and it may go up or down by time. In India, they started the construction of the world's largest renewable energy project. When completed within 3 years, the project will be about as large as Singapore. spreading out over 280 square miles. Once completed, it will supply 30 gigawatts of renewable energy annually, enough to power nearly 18 million Indian homes. The Indian government estimates it will cost at least $2.26 billion. World's largest floating solar power plant is taking shape on hydropower plant reservoir in West Java, Indonesia, to reach a total of up to 500 megawatts. Now, the project in India is taking place in a location where land is not good for agriculture, whereas obviously a floating solar power plant on a reservoir lake does not take up any agricultural land either. Okay, this is USA electricity generation capacity. The green is wind. You can see how it's been going up in the last 15 years or so. Yellow is solar. That's been increasing in the last 10 years. Nuclear is about the same. Lately, there hasn't been much investment there. But coal is definitely going down, whereas gas is going up. Change in electricity generation capacity from 2018 to 22 in 4 years. If you look at it, wind has gone up by 49%, solar has gone up by 117. Gas went up slightly, but coal has gone down quite drastically. Oh, this is the Indonesian solar panels being built on a reservoir lake. Okay, sun is not out all the time, and the wind doesn't blow all the time either. So you need to store the energy. Although lithium-ion batteries are used now, there's a better solution developed in Italy. It's carbon dioxide batteries. Carbon dioxide reaches a liquid state when compressed, and it expands with a pop when released. And now the Italian startup Energy Dome is ready to harness the action for a new energy storage system that could provide far more storage, far less cost than conventional lithium-ion battery arrays. Energy Dome's first project is getting underway in Italy, with completion expected before the end of the next year. A second project is already in the pipeline for the US state of Wisconsin too. Although accidents in Ukraine and Japan scared us all, nuclear energy is still one of the safest and most reliable green energy sources. Some new innovations in fission process and the development of fusion process will make nuclear facilities safer. In February 2022, European scientists generated record amount of energy from nuclear fusion in a facility in Oxford, England. On December 5, 2022, scientists at the US Department of Energy's National Ignition Facility at Lawrence Livermore National Laboratory proved that theory for the first time in a laboratory. In addition, Germany, France, South Korea, and Japan have fusion energy programs underway. The ultimate aim of all these projects is to coax hydrogen nuclei inside to fuse into one heavier element, helium, releasing energy in the form of light and heat and mimicking the process that takes place inside the sun. Of course, fusion, when it is developed, it will take at least a couple of decades yet, is safe. However, fusion technology is also can be made safer. There are several projects going on using sodium instead of water, and also one thing that several facilities, not just in USA but in other countries as well, are developing standard-sized reactors. So we don't have to spend 15 years building new nuclear facilities. And these smaller standard reactors can be made much safer, again, using sodium. A cold spell in Texas in February 2021 gave a black eye for wind and solar power plants. However, it was not just wind and solar plants that were affected by the cold. The natural gas power plants were shut down too. The problem was that Texas was not prepared for cold weather. The power plants were not winterized. Wind turbines are operated in Norway as well, but those are winterized since cold weather is the norm there. Second problem was that the Texas power grid was not connected to national power grid. When they lost power in Texas, power plants were operating elsewhere, but they were not connected. Again, it was the decision of Texas government. If all the states are connected to a reliable power grid, most scientists believe we can do it with solar and wind alone in the USA. Some disagrees. Bill Gates, in his recent book, pushes for nuclear facilities in the USA in addition to solar and wind. But 24% of all emissions come from animals and plants. With agriculture, the main culprit isn't carbon dioxide, it is methane and nitrous oxide, which causes 28 and 265 times respectively more warming than carbon dioxide. Meat consumption is increasing, especially in the developing countries. There are currently roughly 1 billion cattle in the world. Burping and pooping of the cattle and other animals is responsible for a big portion of carbon emissions in this group, basically methane. Cattle in South Africa emit up to 5 times more greenhouse gases than the ones in North America. Improved breed that converts feed into milk and meat more efficiently, and better care will reduce emissions. Plant-based meat today tastes good, quite good, but currently they cost about double the real meat. Anytime we disturb the land, converting wetlands, especially peatlands, to arable land, even ocean trawling, we release carbon dioxide and or methane into the atmosphere. About 60% of methane emissions are linked to human activity, while the rest arise naturally from swamps and melting permafrost. According to a recent United Nations report, if methane emissions are cut by 40% in the next 10 years, this will help avoid around 0.3 degrees centigrade of warming by 2040 and would avoid 155,000 premature deaths each year. Impressive. The measures to cut methane recommended by the report include faster gas leak detection and the covering of landfills to capture their gases, as well as eating less meat. Waste reduction. In Europe, 20% of food is wasted. That figure is 40% in the USA. According to Wasteful CEO Trevor Nelson, every year the world produces over 201 billion metric tons of municipal solid waste, and Nielsen's company is seeking to make something useful out of this crisis by transforming waste into renewable fuels. Crop production has increased by developing bigger grains and adding essential nutrients, phosphorus, potassium, and nitrogen. Nitrogen facilitates plants turn sunlight into energy, so nitrogen makes plants grow, but it also makes climate change much worse. When you apply fertilizer to the plants, half of the nitrogen is taken by the plants, the other half either runs to groundwater or escapes into the air in the form of nitrous oxide. Fertilizers were responsible for 1.3 billion tons of greenhouse gases in 2010 alone. AeroFarms, one of the largest vertical farm companies, this is indoor, is running a vertical farms at Newark, New Jersey, using LED lights with 95% less water and without sun, soil, or pesticides. Isn't that incredible? Ammonia used in fertilizers is produced from natural gas and air that also makes carbon dioxide. There are some new technologies to make green ammonia, but they are not commercially viable yet. Now, deforestation, according to the World Bank, the world has lost more than 320 million acres of forest in the last 30 years. That is nearly 3% of all forests. This caused nearly 30% of all agricultural emissions. Forests are usually reduced for economical reasons. Brazil cuts trees down to increase the pasture land for cattle. Indonesia cuts forests down to make way for palm trees. Agroforestry, growing selected trees and plants together, has been very successful in Brazil. 14% of all emissions come from transportation, cars, trucks, buses, cruise and cargo ships, and airplanes. That percentage is higher for the USA. Gasoline is cheap and it has the most energy, but it also is the biggest cause of carbon emissions in the world. Although the transportation emissions have been dropping in the Western nations, it has been increasing fast in the developing countries as more people buy cars and drive longer distances. It is not just cars, buses, and trucks. Maritime shipping is responsible for 3%, and airplanes are responsible for another 2.5% of the total global emissions. Biofuels is an option, but today biofuels technology does not offer commercially viable zero carbon, low-cost alternatives. More research required to develop low-cost biofuels. Electrofuels are made by mixing carbon from carbon dioxide in the air with hydrogen in the water, but the process is power intensive and currently is very costly to operate. Battery-operated electric cars is the future of the cars. In 2 or 3 years, all manufacturers will come out with different models of electric cars. As the electric car production increases, the batteries will get cheaper and the price of the cars will be lower. Since electric cars are less labor intensive, we could expect them eventually to be cheaper than gas engine cars. But the range as well as charging will stay as problem areas. More superchargers must be installed. Currently, Tesla started long-range cars up to 400-mile range. Technology is still in development. Long before the advent of lithium-ion EV batteries, the US earned a reputation as the biggest producer of lithium in the world, as well as the biggest user of lithium in the world. By the mid-20th century, there was only one mine left in Nevada. Unfortunately, China currently dominates in rare earth and critical mineral mining and refining. The US Geological Survey identified 6 states with major deposits: Arkansas, California, Maine, Nevada, North Carolina, and Utah. In the USA, permitting will probably take at least 6 years, even with the improvements brought in by Biden government, and only then can production ramp up over the course of many more years. In China, it takes altogether 3 or 4 years. Sweden has just discovered the biggest rare earth deposits in Europe. Western Australia supplies half of the world's raw medium and is seen as a stable place to invest compared with parts of Africa where there has been political instability, and Chile where the state has taken control of lithium projects. Although Australia has got a lot of lithium, China has got the largest capacity for processing the lithium. Lithium prices have been very volatile. Lithium prices dropped to $23,000 per metric ton from $76,000 at the beginning of this year. Toyota is developing the solid-state batteries. Cars using this technology would have longer ranges and faster charging times. A solid battery uses solid electrodes and a solid electrolyte instead of the liquid or polymer gel electrolytes found in lithium-ion or lithium polymer batteries, and inherently safer. QuantumScape, a Silicon Valley-based startup, is also in the EV battery market with its solid-state batteries. In fact, I just read that a small car manufacturer, EV car manufacturer, will be using solid-state batteries in their cars starting next year. We shall see. China, according to another article, nearly 18% of all vehicles sold worldwide are electric cars this year, rather last year, 2023. China leads by about 34%, Europe sells about 18%, India 9%, USA trails by 7.6% of sales. Hybrid cars are more popular in the USA, selling about 9%, worldwide by about 11%. You know, a lot of negative propaganda for EV cars in the USA, unfortunately has affected the sale of electric cars. This is a chart showing the number of electric cars sold in the USA. I mean, we've been reading that the car sales are going down. It's not going down, it's going up, but not as high as we hoped it would be. As you see, over 1 million electric cars were produced within the within the 11 months of 2023, and another 200,000 plug-in hybrid cars. This shows the electric vehicles by country. China is producing a large number of electric cars. It's going up drastically. So is in Europe, for instance. In Norway, 95% of the cars sold there now are electric cars. Japan is going up too, and some other countries. Electric buses also a viable option, and some cities like Shanghai has electrified all bus transit. New Jersey will start deploying electric buses in the state, modernizing bus garages with charging stations equipment, and redesigning bus routes. Most train systems in Western countries and Asia currently run on electric power. For cargo and cruise lines, neither batteries nor hydrogen can be used at this time because of the range. Currently, cheap bunker fuel is used in ships. That is cheaper than the gasoline, but ships are also the largest producers of the airborne emissions as well as oceanborne emissions. Maersk is currently testing biofuel option. Another option is hydrogen, but instead of using hydrogen, which has to be liquefied, using green ammonia as hydrogen source. A Financial Times report predicts 54% of the fuel on cargo ships to be converted to ammonia by 2070, 16% biofuels, and 14% on hydrogen. I hope that happens. For airplanes, the only viable solution at the moment are biofuels and electrofuels. 6% of all emissions come from heating and air conditioning of our homes and offices. Most of the heating units in the USA run on natural gas or heating oil. Air conditioning use electricity, but today most electricity are generated burning fossil fuels. Besides, air conditioning units use refrigerants which are fluorocarbons that are major contributors to climate change. In most areas of USA, heat pumps can be utilized today, less expensive than air conditioner gas heaters. Inverter heat pumps can be used down to 0 degrees Fahrenheit according to the claims of several manufacturers. A report from the International Energy Agency found that Europe's developed economies reduced their gas use by 15% in 2022 after Russia cut off flows after its invasion. It found that about 40% of the savings were the result of the mild weather last winter, but the majority were driven by a surge in demand for electric heat pumps and efficiency improvements. Geothermal energy is also underutilized in the USA. IEA estimates geothermal energy can provide world's 3.5% of energy needs.